Washington State University. Go Cougs!
So let's look at a basic on this screen. Let's look at one code. Perhaps we'll take the sum compute serial code, and we'll come back to it. We won't do any change of code right now. We'll just look at the code. And here is one line of code, one program, which essentially what it does is it's basically generating an array of numbers, n numbers, and adding them up. Okay, that's what this code is doing. So the main function here basically takes the arguments from the user and says I want to, initialize an array of this size. This is my n, right, input size, and the number of threads I want to use for parallelism. And we'll use p, the letter p for number of threads, number of processes, or number of processors. Okay, that's the standard notation that people use. Okay. So once you have that, basically we have written two functions here. One is generate the array of size n, and a is the array that you return at the end of it. And then you pass that array with its size to this other function called compute sum, which simply adds all the numbers that's there in that array. Okay. So this is the main function. Okay. The main function really, as you can see, there's hardly anything that evidently you can say we can parallelize, right? Because this generation of the array has to happen before you can compute the sum. So there is a very strict dependency from here to here. So I can't be running this on one thread and running this on another thread at the same time. There's no point, right? So here is the generate array function. So let me actually go to the compute because it's easier to parse. So here is essentially my serial code to add up n numbers. Okay. So all I'm doing is I'm saying I equals 0 for I is less than the number of elements n, I plus plus. I have initialized result sum variable, sum equals sum plus whatever is the ith element in that array, a of I. Okay. And at the end I can output sum, which is my answer. So it's a simple for loop. So the question is, what can you parallelize here? Can you parallelize this? If so, how? High level strategies, any ideas? Let's say I have like 4 cores, yeah. Yeah, let's say I have 4 threads at my disposal. Let's say I have 4 cores at my disposal. Let's say I created 4 threads. So 4 threads are waiting for work to do, right? And so I have an iteration. So just like you said, let's focus on the loop, right? So the loop is where the parallelism is, right? So the main thing is, this is a serial code, and if you think about it, actually, the way it's written, right, is the first time you enter the loop, sum is equal 0. Then you add up the first entry, the 0th entry of your array, and add it and update that to the sum. The next iteration, you take the sum that's stored so far, that's computed so far, and add the next element to that sum. So basically you are keeping a running sum and growing that sum as you go to the n iterations. Yeah. And then aggregate them, right? So basically breaking the array is the technique that you're referring to. That's great, because we have an array of size n. N is presumably large, right? That's why we are interested in using parallelism, right? N could be a million or a billion. So if you want to break that n into smaller chunks and add up or create a partial sum for those individual portions and somehow merge them, basically you need to simply add the partial sums to get the global sum, right? That gives you a good level of parallelism. So what that means is essentially you want to, in there you can do load balancing in a nice way, because to add 2 numbers is the same cost in time. So you can assume that and say, hey, I have total of n elements, p threads, n divided by p will be the number of elements that each processor or each thread will get, and they have to generate their sums. Basically, they will have to execute their serial code to create their partial sums, and then there has to be a way to merge those results, combine those results, right? That's a high level strategy, and that's what I was hoping to get, essentially some way to understand how this can be parallelized first. It's a very simple code, right? So we have to start highlighting places of the code that can be parallelized and that cannot be, right? So this is a simple example for that, and we will actually parallelize this after.